In this part of the course, we're going to explore how some formal methods borrowed from decision theory and game theory might enhance our understanding of the discoveries about action and about joint action. We're also going to explore, of course, how those discoveries might bear on our use of these formal models. Although this is going to seem quite dry at the beginning, when I've taught this course in the past, this was one of the areas that most interested people in the end. So do bear with me. Very simple idea for the beginning. So decision theory, sometimes people talk about rational choice theory. Simple question, how do rational agents decide which of several available actions to perform? Now, you noticed earlier we didn't try to answer this question at all. When we were talking about the problem of action, for example, we just assumed that the agent somehow arrived at an intention. But it wasn't of interest to us to understand what intention it might be rational for the agent to perform, or indeed whether or not there might be anything to say about the rationality of intention. As you'll see in a moment, proponents of decision theory are people who think that there are facts about what it's rational to do, more rational and less rational. Now there is, if you like, a special case of decision theory, but also an extension of decision theory called game theory. It's a special case because in a sense game theory involves a sort of simplification of decision theory, and it's an extension because game theory allows us to study not just individual agents, but rather agents who are interacting with each other. So a game theorist is often trying to answer this question: when two or more agents interact, so that which outcome one agent's choice brings about depends on how the other chooses, and conversely, how should their preferences guide their choices on the assumption that they are rational? So what we will do is first of all think a little bit about decision theory and then think about game theory. But what I want to do in this section is just to introduce you to the kinds of representation which are used. For that reason, it's important first of all to talk a little bit about the motivation. The best thing to say about the motivation of people who study decision theory, game theory, and theories in this area was already said by some of the pioneering figures, von Neumann and Morgenstern. They said, "We wish to find the mathematically complete principles which define rational behaviour for the participants in a social economy, and to derive from them the general characteristics of that behaviour." So here we have a super lofty aim, and of course one of our questions will be to what extent that is possible and what assumptions they're relying on. So as I said, we're going to start with trying to understand how actions are represented from the point of view of somebody who wants to go on and construct decision theory. So in a sense, what we're doing now is just the simple background. What does the representation look like? Let's be sure we understand it. So here's a very simple situation. You're on a game show and you have a choice. You can open the red door or you can open the blue door. So those are your actions. You just have two possibilities and you must do one of these. You can't do both. Now your actions can have various outcomes. So if you open the red door, you might either be awarded no money or £100 million. On the other hand, if you open the blue door, you might get £100 or you might get £200. Now if I ask you at this point which door are you going to open, it's kind of hard to make any sense of this because I've got no idea and you've got no idea what kind of probabilities might be involved and what kind of values there might be. So the first thing we need then is to work out what your preferences are. And it should be clear that you don't necessarily have preferences which scale linearly with money. So for example, once you've got your first £100, the next £100 taking you to 200 will be a bit less interesting. So we might think that roughly speaking, you're about half as much again interested in the £200 as you are in the £100. And the £10 million, well, that is a lot more exciting, but it's not like 10 million times more exciting, right? Or 10 million divided by 100 times more exciting. So here, let's suppose, are your preferences concerning the different outcomes. Now at this point it looks like, look, I mean, this is clearly the most preferred outcome, second most preferred, third most preferred outcome, least preferred outcome. Very simple. So we can rank these things. That's very good. But the other thing that we need to know is, look, what are the probabilities? What are your expectations about what's happened? Now I'll tell you what I've done. In the case of the blue door, what I've done is I've tossed a coin, and if the coin is heads, I've put down £100, and if the coin is tails, I've put down £200. The coin is fair, so there is a 50-50 chance of £100 and a 50-50 chance of £200, and that's what you expect. That's your subjective expectation. Now I tell you that in the case of the red door, what I've done is this. I've gone out, I've put down £1, and I've bought a lottery ticket. I bought a lottery ticket. And with that lottery, I'm not sure, do they still cost £1? I don't play the lottery. The odds are not really in your favour, actually. I don't encourage you to do this either. But of course, it depends on your preferences, whether you really should do that. In any case, what I've done is I've gone and bought a lottery ticket, and I've put the winnings behind the door if I've won the jackpot. And if I haven't won the jackpot, if I've won a smaller amount, I've just kept it for myself. So you've either got 0 or you've got £10 million because it was a rollover week. But of course, the probability of you having £10 million is a very small number. So what should you do? Should you open the red door or should you open the blue door? Well, one way to think about that question, one way, not the only way to think about that question, but one way to think about that question is to think, well, look, what would be the expected utility of the action? And to calculate the expected utility, what we do is we multiply the probabilities by the preferences that you have. So in this case, we think that there are 13 units behind opening the blue door. By contrast, when we look at the same function, expected utility, for the red door, we see that we multiply the high probability by the outcome of 0 and the low probability by the outcome of 10,000. In that case, we get roughly 0 there. What this tells us is that opening the blue door has higher expected utility. And so if you were using expected utility, if you knew how to rank your preferences and what your expectations were, subjective probabilities, then you would, of course, choose the blue door over the red door. Not that everybody does that, but my point here is to try to tell you something about what this expected utility is. Now, some people will already find this very familiar, in which case what I think is important is that you're just clear about the terminology that we're going to use in this course and you're sure that you can use it consistently. But you might be someone who says, look, Steve, I just don't really get this expected utility thing, and that's fine. What we're going to do is think about that in terms of a true story. So we're going to take a step back now and just think about a little bit of gambling. I'm going to tell you a true story about a bet. And this for me is a bittersweet story. So I was very upset with the political developments in the US, in Britain, Brazil and other cases where it seemed like, populist forms of government were taking control, were seizing control. But I also thought to myself, look, this is actually an opportunity to make money, because this is a situation in which many people are very susceptible to false beliefs. So there was a point in time in the US-American election that Trump lost, where all the votes had been counted. We knew how all of the states had voted, and the only thing that was left was for the, I think it's the Senate or the House of Representatives, then to decide who would become president. But that was supposed to be a formality. That was always supposed to be a formality. And at that point, I was offered a bet. You were offered a bet. Anybody could have taken this bet. And the bet went like this. If Trump did get elected at this point, you would lose £1,000. If Trump was not elected, you would gain £100. Why is that interesting? Well, let's say, I think roughly the probability of Trump being elected at this point would be something like 1 in 100. So what this would require is a kind of coup of the in the USA. It would require a kind of a political change of power from a democratic system to a non-democratic system. So I thought the chance of that happening was probably 1 in 100 or perhaps less than that. Now, as it turned out, I may have been a little bit over-optimistic here. It's a little bit unclear how optimistic I was being, and I guess you will find out before too long, probably. Hopefully I wasn't being too optimistic. So what this tells me is, look, I can think about the bet like this. There's a roughly 1 in 100 chance that Trump will actually be elected after all. So all of the people have voted, the states have registered their votes. It's just the House that now has to say who's actually won, who's actually won. So they could go against the Constitution and choose Trump if they wanted to. Now in that case I would say, look, okay, so this is minus £1,000 times that 1 in 100 probability. On the other hand, the chance of winning is 99 out of 100, so I do 99 out of 100 times the 100, and then I just add those two things up, and that tells me, look, I've got 89. So what am I doing here? I'm taking the probability of the outcome, multiplying it by the expected gain, and that gives me a number. I'm adding those two things together, the two resulting numbers, and that says to me, look, I expect to get £89. Right. So here we're doing very simple high school mathematics, but useful mathematics because it's telling me that this bet is actually quite valuable. This is actually, the odds are quite nicely stacked in my favour. Why didn't more people take this bet? Well, first of all, I think actually a lot of the money in this particular betting market was people who had listened, unfortunately, to Trump saying some wildly incorrect things, and they accepted what Trump was saying, and so their estimation of the odds was quite different from mine. The other thing is that you can only actually take this bet if you're in a position to lose an awful lot of money, right? You have to be extremely wealthy to take this kind of bet, whereas taking the other side of it is involves putting less at stake. All right, so what's the thing that interests us here? The thing that interests us here is that we can use this idea of multiplying the probability of an outcome by the expected gain of that outcome, and as long as the outcomes are mutually exclusive, we can add those things up to give us a sense of what we expect to get. It's a very simple, very familiar idea. Why am I going on about this? Because this simple, familiar thing is essentially all you need to understand expected utility. But let's do one more of these. So let's now imagine that we're thinking not about a single action, but a choice between two actions. So I'm going to offer you two bets, and you can take exactly one of these bets. Either you can roll a fair dice, and if you get a 6, I'll give you £90, and if you roll anything else, I'll give you £30, okay? Or you can toss a fair coin, and if it comes up heads, I'll give you £60, and if it comes up tails, I'll give you £40. Very simple question. Which of these two actions should you perform if you just want to maximize how much money you take from me? You want to take some of my money. Which of these two actions should you perform? Well, what we need to think about is how the potential gain relates to the probability of the different outcomes. So for example, there's a 1 in 6 chance of rolling the 6 on the fair dice, and so we could think that, and a 5 in 6 chance of rolling anything else. With the case of the coin, it's a 1 in 2 chance of the heads and a 1 in 2 chance of the tails. Now what we're going to do is think about the expected gain of the different actions. So in the case of the first action, rolling a dice, we're going to multiply the potential gain 90 by the probability of that outcome, and then we're going to multiply the second thing, which is the potential gain and the probability of the second outcome. And that altogether is going to give us, I think if I got this right, that's going to give us £40. Yes, it's going to give us £40. I'm not promising that my adding up is right. I'm pretty terrible about these things, but you get the idea here, right? So if you take this first option, what you're expecting to get is £40, although it could be quite variable. If you take the second option, so again, we're multiplying the different outcomes by the probabilities, what you'll see there is that you are expecting to get £50. So if your goal is to take the maximum amount of money possible from me, this is the better option. What you will expect on average to do with this option is to take £50 off me, whereas this one will be less costly. So I take it this is an extremely simple, familiar idea. We're just using really simple maths to work out which of two possible bets would be the better one for you to take. But if you follow this, then you certainly understand the notion of expected utility, because expected utility is a bit like the value of a bet. What we've done in the case of the expected utility is to multiply what you think subjectively the probability of an outcome is likely to be by how strongly you prefer or disprefer that outcome relative to the other outcomes, and use that to generate expected utility. The key difference here is this. As I said at the beginning, your preference ranking doesn't necessarily correspond to monetary value. So in this case, I'm supposing that your preference for gaining £200 is a little bit more than your preference for gaining £100, but it's not massively more. And indeed, you might quite reasonably have a very low preference for gaining £10 million. That will make your life much more complicated and force you to think about some very complicated problems. If you're in a very luxurious position already, if you're in a very fortunate position already, it may well be that you regard coming into a large amount of money as more trouble than it's worth. Right? Of course, most people won't think like that, but you could do in principle. And that's why when we're thinking about expected utility, we're not thinking about how much money you expect to earn or how much anything else you expect to earn. We're thinking about how good the outcome is relative to your preferences and the probability of it happening. Very simple. So what I want to stress here is that we're just looking so far at a way of representing actions and assigning to those actions an expected utility. So we haven't done any interesting theory yet, we haven't made any interesting claims. We're just thinking, look, there's a certain range of actions that we can represent in this way. And in doing that, we've used some terminology. So we've thought actions have outcomes, or as Jeffrey says, consequences. We think that which outcome an action causes depends on what condition obtains. We think that the subjective probabilities attach to these conditions. We think that preferences are things that rank the outcomes, not the actions. You don't have preference in this view for one action over another, but rather for the different outcomes that your actions can have. But the expected utilities are things that attach to actions. And the idea, of course, is going to be essentially the idea that a rational agent chooses the action with the greatest expected utility, what Jeffries calls estimated desirability. So if you understand the terminology and you can map it on to my simple example here, then you're already good. You've got everything that you need to carry on. So the thing we've done so far is to look at the representation of actions that we need for decision theory and game theory. We haven't yet got any of that theory in place. We haven't yet got what von Neumann and Morgenstern are hoping to will be mathematically complete principles which define rational behaviour. What a fantastic idea. So here's what we're going to do. Understand the representation. We're partway there, but what we've done with understanding the representation is to understand it for the case of individual action. Our next step is to extend the representation to interacting agents. It's going to get gradually more fun as we go. And then the third thing that we will eventually do after that is to ask the question, well, what are these preferences of which we speak? So far I take it that subjective probabilities actually, preferences and expected utility, we've understood those things in a formal sense, but we have got no idea which things in the world they are supposed to be. No idea at all. And so that is the third step that we need to take.